Introduction. Rapid development in advanced countries necessitate efficient road infrastructure due to its role in connecting different places. Road pavement needs periodic repair based on the extent of damage and distress it faces, which can vary due to factors like temperature changes, traffic volume, moist content, and subgrade movement. Various initiatives, including research on bituminous material, aim to ensure quality road construction, reduce maintenance costs, and develop better maintenance procedures. Damage to road pavement is classified into six categories, including cracks, surface deformation, edge defects, potholes, and patches caused by various factors. Several techniques have been proposed to address road pavement damage, aiming the easier utilization by relevant parties and ensuring user safety and comfort, as well as management profitability. Study. Pavement failure can be surveyed and categorized based on visible damage and the Pavement Condition Index (PCI) rated from 0 to 100 is used to numerically assess pavement conditions where 0 represents the worst state and 100 the best. The project is situated on Jalan Delta 1, around 1 kilometer from section of road suffering from various issues like potholes, depressed areas, alligator cracking, and bleeding. Studies were conducted on the road to assess its pavement condition index (PCI) and determine if the road is in good condition. The aim is to ascertain if minimal or comprehensive maintenance is necessary to rectify the existing damage. The damage to road pavement is categorized into two types: function damage and structural damage. It is caused by environmental factor, pavement layer thickness, and increased traffic load in the area. So next, for the objective, first, to determine the type of pavement damage that has occurred. Second, to calculate the damage to determine its extent with data. And lastly, to discover the pavement restoration process. Thank you.
For methodology, we need to choose the study area which is in Jalan Delta 1 at UTHM, and then we need to borrow the equipment FF Cup Traffic Laboratory to execute the the study, and then we choose the road with the most failure as our first end, and then we need to classify all of the type of failure at that section, and then we jump into the next section by interval of 2. We need to collect the data to determine the PCI index, and then make a final report and do the calculation. after we got the After we got the final result, we need to recommend a maintenance or a rehabilitation method.
In order to record the deformation on the road, we need to use some equipment in order to help us do the task easier. Such as one of the main equipment that we use is the wheel meter, which we use to measure the distance of the road that we calculate. And then we also use the safety cone to warn the drivers on the road that we are doing work so they can move slower and avoid fatal accident. And finally, we will wear the safety vest so they can see us clearer and avoid us in case if anything happens. Another main equipment that we use is the ruler and the measuring tape, which we will use to like, measure the size of the deformation on the road, such as the potholes and the cracks. And then we will use the PCI table to record our deformation. And finally, we will put it in the report to do some analysis. As you can see here is a video of us using the measuring meter wheel to measure the section of the road distance, such as for the first section we will count about 100 meter, and then we will count about another 100 meter for another section. And here we have a video of two of our group members using the measuring tape, trying to measure the width of the road. And here we have a video of two of our. For the next step, which is step 3, we start to find the distress that is available on the research survey section, and we classify the distress into their types, such as this one will be potholes type, and in the future slide we will have more types to see. After deciding what is our type of distress that we found, we will start to measure the length of the distress by using the measuring tape we have borrowed. Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Shekar, and right now I'm going to present our data analysis from our group. Based on this equation here, we can acquire that our interval is 2 because using the formula big N over normal N, big N means the total number of sample unit session, which is 10. We got 10 sample, and then 5 is the minimum number of sample need to be expected. So our total is 2. That means like we need to calculate a sample every two units, every two section. The steps that we do this the analysis is by, the first one is to determine the distress density and deduct value, and then we determine the maximum allowable number of deducts, or M, and then we determine maximum character deduct values, or CDV, and then finally we determine the pavement condition index.
So in this right, we do the analysis of section 1. First step, we determine the distress density and deduct value. So from the table, we can see clearly that is the highest deduct value is 41. And the formula we can use to determine the density is total times the sum of the quantities divided by the sample area times the 100. So the highest deduct value is 41. We apply the formula 1 plus 9 divided by 98 times the 100 minus HDV. So we can get the value is 6.42. So the deduct value then descending order is 41, 23, 16, 14, 5, 0, and last value is 0. So the maximum allowable number of the deduct value is 6.42, smaller than 7. So they are the only 6 and 0.42 of the 7's deducts number. So the selected deduct value is 41, 22, 16, 15, 5, and 0. Moving on, second step, determine maximum collected deduct value CDV. So in the table, we can see clearly the 52 is the maximum CDV in this PCI survey stance of the sample ones. So the total deduct value we summarize all the deduct value, so we can see that we can get the value is 99. And we apply the maximum CDV in the equation below. PCI equal to 100 minus CDV max. So we can get the value is 40x. So based on the table of the PCI, so we can see clearly the 40x of the sample of unit 1 is in poor conditions. Moving on, analysis of section 3. As usual, we need to determine the distress density and deduct value. So in the table, we can see there has the highest deduct value is 53. So we apply in the equations 1 plus 9 divided by 90x times the 100 minus HDV. So we can get the value is 5.316. So the number of the deduct value is equal to 7. And since the maximum allowable number of the deducts is 5.316 is smaller than the 7, so therefore only first 5 and the 0.316 of the 6 deducts value are selected. So that is the 53, the 22, 16, 11, 4 and 0. After that, we need to determine the maximum collected deduct value, CDV. So in the table, we can see clearly the maximum of the deduct value is 55. So the number of the deduct value greater than the 2 is Q equal to 5. So we can see clearly we apply the 2 and we can calculate the total deduct value is the 106. So we apply the maximum CDV is 55. So we can determine the pavement condition index PCI. So PCI test is equal to 100 minus 55. So we can get the value is 45. That is in the conditions, poor conditions category. So next, we do the analysis of section 5. As usual, we determine the distress density and deduct value. So we can get the maximum allowable number of the deduct is 7.153. So the deduct value in descending order, which is from the bigger to smaller, which is 33, 19, 6, 13, 11, 11, 9, 7 and 0. So the number of the deduct value is equal to x. Since the maximum allowable number of the deduct value is smaller than x, so therefore only 5, first 7 and the 0.153 of the x deduct value are selected. So same as the progress, determine the section 1 and 3. We determine the maximum collected deduct value CDV. So the number of the deduct value greater than 2 is equal to 7. So the total deduct value, we get it in the table and is 103. And the maximum CDV is 50. So we can determine the pavement condition index. So the PCI equal to 100 minus 50. So the answer we get is 50. So that is in the category poor conditions for the road surface. Now we do analysis of section 7. So same as the step previously, we can determine the distress density and deduct value first. So we plot the table and we insert the value in the table. So there has the 5 columns. We can get the deduct value. Highest deduct value is 41. So we apply the highest deduct value HDV in the equations below. We can get the value is 6.41x. So the deduct value in descending order is 41, 23, x, 6 and 0. So the number of the deduct value is 5. Since the maximum allowable number of the deduct value 6.41x is bigger than the 5. So therefore all the 5 deduct value is in use. Next, we determine maximum collected deduct value CDV. So from the table, we can see clearly there is the number of the deduct value greater than 2 is equal to 4. So we can see the total deduct value is equal to 70x. and the maximum CDV is 44. So we apply the 44 in the equation PCI equal to 100 minus CDV max. So 100 minus 44 is equal to 56. So the sample of this unit 7 is in far conditions. So there is the PCI text for the section segment. Now we do the analysis of sections 9. So as usual, we determine the distress density and deduct value. We can get the highest deduct value HDV equal to 17. So we apply in the equations. We can get the number and the value is 8.622. So the number of the deduct value is 4, and since the maximum allowable number of the deduct value is bigger than 4, therefore they are all the 4 deduct value is in use. Next, we determine the maximum collected deduct value CDV. So we apply that, and the number of the deduct value greater than 2 is equal to 1. So the total deduct value is 19. The maximum CDV is 19. So we apply the maximum CDV in the equations PCI is equal to 100 minus CDV max. So 100 minus 19, we get the value 81. So this sample of the unit 9 is in satisfactory conditions.
For discussion, our initial parameters is n, number of section is 10, and number of section assessed is 5, so our interval is 2. Road division is we have the 1 kilometer road divided into 10 section with intervals chosen based on the calculated value. Our PCI assessment is section 1, 3, 5, 7 and 9 were assessed. PCI values is 48, 45, 50, 56 and 81. Maintenance recommendation based on our PCI and level of service is section 135. We need to do the major rehabilitation needed, and section 7 need to do the rehabilitation. For section 9 we need to do the preventive maintenance. We need to detect and repair pavement defects using specialized techniques like crack sealing, joint sealing, fork seal and patching, because it is to prevent or slow down the rate of pavement deterioration. Despite good design and construction, pavement deteriorate due to traffic loads and environmental conditions. In conclusion, after several discussions with all of the team members, we decided to do the maintenance in part because only half of the section needed to do major repairs. In contrast, half of it needed to do a bit of repair and maintenance.